Hi folks, I want to talk a little bit today about utilizing artificial intelligence in the secure engineering space. There's been a lot of buzz around artificial intelligence. One way that we can leverage AI is within not just secure engineering and not just engineering alone, but combining those and creating a way to develop software in a secure way, leveraging artificial intelligence. Before we get to that, a little bit about myself. So I've been in engineering for roughly 25 years, maybe a little bit more, and I've spent a lot of my time in the hardware space, software, and then cybersecurity. And my experience has been primarily around healthcare, commercial, military space, as well as the financial space where I've been for the past several years. I'm a recognized leader in cybersecurity. I have several award-winning books. I've written a children's book series on children being able to use technology safely and securely. I have a application security program handbook that is out that walks individuals through the steps it takes to build an application security program within an organization. I do a lot of industry conference speaking. I have been teaching at university level for about 6 years now at Temple University in Philadelphia. I also have several education courses online available. You can find them online. I've been primarily focusing on product and application security through my security journey, and I actively contribute to the cybersecurity community through platforms like LinkedIn, as well as through my education and thought leadership in terms of blogs and newsletters and things like that. So I appreciate you taking the time here to learn a little bit about my thoughts around application or around artificial intelligence and integrating that with development to create secure engineering. All right, so first of all, I just want everyone to understand that yes, I used AI for this presentation. And lastly, no, I am not an expert on artificial intelligence. A lot of what I'm going to show today are things that I've just learned by doing some research in artificial intelligence based on my knowledge around security engineering and software engineering in general. But I'm hoping that I can at least impart some information that I've learned throughout that journey that can help others understand how we can integrate artificial intelligence with software engineering. So let's start out first and talk a little bit about what actually is artificial intelligence. Well, artificial intelligence refers to the simulation of human intelligence processes by machines encompassing learning, problem solving, and decision-making capabilities. Basically, how do we mimic human activities through the use of machines, in other words, artificial intelligence. So what does that mean? Well, artificial intelligence in reality is a broad discipline with origins dating back to the 1950s. One of the first instances of artificial intelligence being used was the logic theorist, developed in 1956. It centers on developing machines that can imitate human intelligence, as I mentioned, and it spans several different diverse technologies. Those technologies include things like machine learning, generative AI, and large language models, which is a lot of what we're going to talk about here coming up. So let's start talking about large language models, GPT, and chatbot. We'll start off with large language models. So large language models are a type of AI that has been trained on a widely available set of data like articles, internet resources, books, and other sources. GPT has been wildly popular lately, and that is where a lot of the responses that you get from GPT are responses that have been derived from what it knows based on scraping the internet. So the short story here is that LLMs are language models or language wizards that have been trained on large sets of text so that they can predict the next word in a response until the answer is complete. What that really means is that it's a statistical estimate. Something to point out here is that newer models will be trained on specific and customized data sets. And additionally, models will soon begin to shrink as they are more purpose-built, more efficient, while gaining sophistication. So I want to go back to one of the terms I just mentioned there, a statistical estimate. So for example, you may say, I want to ask a large language model, for lunch today I ate, and then you're going to stop. And a large language model could come back with several different options, one being cereal, rice, or steak tartare. While not 100%, there is a high probability that the answer cereal might be the next correct answer based on existing data. So the LLM could complete the sentence with that word. But because the LLM is a probability engine, it assigns a percentage to each possible answer. So cereal might occur 50% of the time, rice could be the answer maybe 20% of the time, and steak tartare might be 0.005% of the time. So getting back to the term statistical estimate, essentially it's trying to estimate or predict what that next word is in that sentence for you based on weights that it is given to different types of words that it knows about. So let's talk about GPT, or Generative Pre-trained Transformer. So GPT is a family of neural network models using the transformer architecture, in other words, a language translation. This powers generative AI applications, enabling the creation of human-like text, images, music, and more. And it's applied in various industries for question and answer bots, text summarization, content generation, and search. It enables digital marketers, professionals, and educators to leverage AI for various applications, from generating content to creating learning materials. I've used it very heavily in a lot of my education material, especially when creating quizzes. So I'll take my content and I will ask it to create a couple quiz questions based on the content that I have. And then of course, we'll get into this in a little bit, but you want to make sure that the output coming from those GPTs are actually valid and make sense, and bounce that off of what you know and what you fed it. So for our purposes, a key use is GPT's ability to write and learn code. So next up, let's talk about chatbots. Some of us are probably pretty familiar with chatbots, but a chatbot is essentially it employs a large language model such as GPT, and it's an advanced conversational agent designed to understand and generate human-like text responses. So by utilizing extensive pre-training on diverse language datasets, it excels in processing natural language inputs, providing contextual, relevant, and coherent messages. This makes it approachable for users in various domains for interactive and intelligent conversations, and it's often indistinguishable from a human conversation. So many of us have had interactions with chatbots, maybe in the old days, I say a couple years ago when I say old days, but maybe a few years ago when you had a conversation with a chatbot, it was pretty clear that you were having a conversation with something that was not quite as intelligent. It was easy to basically get through maybe one or two questions. The chatbot would hit its limitation. But nowadays, the chatbots that are integrated with things like GPT are much more intelligent and can actually carry on a conversation. And it's very hard sometimes to distinguish, am I actually talking to a real person or am I talking to a bot? So let's put all this together. So AI is the overarching field that encompasses the development of intelligent machines capable of performing tasks that typically require human intelligence. LLMs are a type of AI model designed to understand and generate human-like language. GPT is a type of LLM that uses transformer architecture. GPT models are pre-trained on massive datasets, as I mentioned, and this allows them to generate high-quality text and respond to diverse natural language inputs. And then lastly, chatbots are applications or programs designed to simulate human conversations. They leverage AI technologies, including LLMs like GPT, to understand user inputs and generate appropriate responses. So why we're here is to really start talking a little bit more about how we can use artificial intelligence in development environments. So I call this AI coding assistance, and you'll see that term being used by some of the vendors as well. But an AI coding assistant is an innovative software tool that harnesses the power of artificial intelligence to enhance the coding experience for developers by integrating with popular code editors. Some of the key features that you'll see in these AI coding assistants is automatically generating entire code snippets in response to prompts or code comments, identifying and highlighting errors, bugs, and potential security vulnerabilities within the code, facilitating code commenting, ensuring easy reference and comprehension for developers. Some of the benefits that you see using an AI coding assistant is going to be the ability to accelerate code writing and free up time for creative problem solving. Being able to provide suggestions while coding, enhancing the development workflow. And then serving as a valuable learning tool for exploring and mastering new programming languages. So just my 2 cents on some of this is that I'll go over this here in a moment, but I used Copilot and Code Whisperer when I was doing some research around AI coding assistants. And I haven't been a developer in a enterprise capacity in quite some time. I still write code every now and then, but it's really for projects, not really doing it at the enterprise level. But one of the things that I enjoyed most about Code Whisperer and Copilot is that it really, one, brought back the excitement and fun of writing code, but two, it allowed me to write in a language that I haven't written in before. And by doing so, I was able to really, if you understand how code is written and you understand logic flows and things like that, learning another language, another coding language, is not that much difficult, or not much more difficult than what, getting back on the horse or getting back on the bike, as we would say. And so the ability for these coding assistants to really help individuals learn new languages and learn how they work within a development environment really, again, kind of helps that learning process. And it really takes a lot of the sort of mundane aspects of coding out of the hands of the developer, and things like commenting, code commenting, creating unit tests. These can all be offloaded to an AI coding assistant to be able to perform those things and allow the developer to focus more on the problem-solving techniques. So you might ask yourself, well, can't I just use ChatGPT? You can, but oftentimes ChatGPT produces wrong answers to software programming questions more than half the time, according to a study by Purdue. Now, we can also think about this in the sense of, for those of us that have written software in the past or are still writing software, if you go to a place like Stack Overflow, you might ask a common question, you might get 10 responses. Some of them may be right, some of them may be wrong, some of them may be more right than some others. But the point being that there's multiple different answers. And that can oftentimes create a bit of confusion in the way that GPT is going to respond, in the sense that it's learned what it thinks is the proper response to that, but there's multiple different options for it to choose from. Therefore, it's likely that I don't want to say likely, but there's a probability that you are going to get the wrong answer. Another concern is what we call drift. And drift refers to when LLMs behave in an unexpected or unpredictable way that stray away from the original parameters. And this can happen because attempts to improve parts of a complicated AI model cause other parts to perform worse. So as the model is being further trained and further honed, it can make it actually perform less good in certain situations. So an example of drift is when machine learning models trained to recognize spam emails start misclassifying them because the characteristics of spam and non-spam emails have evolved, but the model hasn't been updated. All right, so let's talk a little bit about paired programming. So Replete is an online coding platform with a browser-based IDE or integrated development environment, and the standout feature, Ghostwriter, is an AI-powered coding assistant. As I mentioned, Amazon Code Whisperer is a machine learning powered code generator, provides real-time code recommendations within the IDE, It's been trained on open source code. It automates tasks, supports multiple languages and development environments, and enhances precision and security by following industry standards, an invaluable tool for efficient, accurate, and secure coding. Tab 9 is another one, which is AI-driven coding assistant. It accelerates code writing in multiple languages like Python and Java. With smart, complete suggestions and error identification, it adapts to individual coding styles. Lastly is GitHub Copilot. This is a leading AI coding assistant, transforms coding with efficient code suggestions, language learning, and quick debugging. It's powered by OpenAI Codex, and it suggests lines, completes functions, and enhances security. So both Code Whisperer and Copilot, as I mentioned, were two that I really kicked the tires on a little bit. And they integrate nicely into VS Code, which was the IDE that I was using, and offer simple suggestions. Code Whisperer does a good job of describing how to implement the code, which was very nice. So what about some complex code? So a prompt that I wrote here says create a function that implements a complex algorithm with multiple loops and conditional statements, showcasing algorithmic complexity. So it wrote this function, which of course looks a little bit more difficult, but in reality, all it's really doing is checking if the variable I is an even number. If it is, it multiplies I with j and adds the product to the variable result. So it looks complex. Reality, it's not really doing a whole lot in terms of functionality. So what about a very specific function? So here I mentioned my prompt, I should say, is write a function that takes a username as input and queries a table called accounts in a SQL database. But what's wrong with this function that was generated by Copilot? If you look closely, you'll see that it's basically concatenating the username to a select statement and then running that against a database immediately. That often is indicative of a SQL injection attack. Now, of course, I didn't ask it to write a secure SQL select query, but all I asked it to do was write a function that takes a username as input and queries the table. It did exactly that without a lot of the security controls around it. So this is just simply to highlight that those types of security issues are not automatically integrated. So that leads us to potentially dangerous curves ahead. So what are some of the security considerations of AI? Well, there's an over-reliance on autocomplete. Developers may become over-reliant on AI autocomplete suggestions, potentially copying and pasting insecure code without fully understanding what the implications are. If a developer solely develops on AI-generated code without a solid understanding of security principles, they may inadvertently introduce vulnerabilities such as SQL injection or insufficient data validation. AI models might not always be up to date on the latest security threats, so developers may inadvertently use outdated or vulnerability coding patterns suggested by the AI. Developers may also have a false sense of security when using AI-assisted tools because they may be assuming that the vendor that produced that AI tool that they're utilizing has already considered the security considerations. And lastly, relying solely on AI-generated code without thorough testing may result in overlooking potential security issues. There's also very direct attacks on AI. So we may have heard of things like prompt injection or data poisoning or model theft. But as I mentioned, there's things like over-reliance, there's excessive agency, insecure plugin design, sensitive information disclosure, which is another hot topic when it comes to AI. And then, of course, there's supply chain vulnerabilities. So this is utilizing third-party tools, third-party systems. Those third parties could be hijacked and leave the organization open for further attacks. And AI can actually be fooled as well. So it's not, seems like a silly picture, but in reality, self-driving cars can be fooled into believing that they are trapped. You can slap the word iPod on an apple and the AI system may think that now it's an iPod. Putting deceptive markings on the road can obviously have dire consequences for self-driving vehicles, and being able to recognize certain signs or being able to recognize the surroundings, the AI could often be fooled by just little tweaks to signs or misplacement of signs. And the other important thing is AI can fool us too. Neither of these pictures are accurate. However, you could understand that there's maybe the one on the left is a little bit on the silly side, the one on the right could be inflammatory depending on the situation. So AI can be used to generate perhaps images and deep fakes, things like that, to actually fool us into believing something that isn't true. So now that we know the dangers, let's talk a little bit more about what AI assisted development can do for us. So here's a prompt that I entered into Copilot saying, generate a code snippet that showcases common security vulnerabilities, including aspects like SQL injection, insecure data handling. And in the prompt, I want the Copilot to highlight some common mistakes could lead to security risks, and then also provide explanation and suggestions for improvements. Well, it did that. It provided some examples of SQL injection, but it also gave me some examples of how to create more secure code by providing those improvement considerations. Also, one of the things I liked about Copilot was being able to ask Copilot for help with a specific statement. So here I asked Copilot to provide a little bit more information on the SQL statement. It provided a good summary of the code. One point that it mentioned here, without me asking for it, is it mentioned that there is a potential for SQL injection in the code that was written. It recommends using a parameterized SQL statement and a helpful follow-up on how to prevent SQL injection with specific fixes. And you can see here, it states preventing SQL injection in your Python code. You should never directly concatenate or format user inputs into your SQL queries, and then provides an example of using a parameterized query. So that's great, but is there more? Well, we can create something like, just kind of playing around here, but let's say we create something called DerekBot 3000. And ideally, we want our developers to write code and give them the tools they need to write it securely. We want to build the utopia of secure development, and that's what we're talking about here, this DerekBot 3000. So in order to do that, perhaps we want to offload things like code review to a bot. And we can integrate that within the development pipeline, within the code check-in, and ensure that there's been some level of design and code review to ensure that the check-ins are free of security issues. Within threat modeling, there's a lot of buzz in this area right now, and orgs are looking for ways to shorten the amount of time that it takes to create a threat model. So ideally, if we can offload at least the bulk of the difficult aspects of threat modeling to a bot or to AI more specifically, to identify the threats given a design and tell us what the remediation should be for those threats. And then of course, as we've seen, there is development environment integration that can be utilized with artificial intelligence. This is likely going to get better and more robust as time goes on. Perhaps real-time correction in the near future is something that we'll see. And ideally, we want to get good remediation suggestions. So there is a tool or a project by OWASP called OpenCRE. And that's one example of being able to utilize artificial intelligence to generate remediation suggestions based on information that's available from reputable sources. And this could be pulled from industry remediations and organizations like OWASP and so forth. And then of course the last part here is operational support. So we want to demystify what's going on in ops and make it relevant for the development teams. That means grabbing data from operations and bringing that back to the development team so that they understand what the security issues are that are impacting their application as it's running in a production environment. So what are some of the benefits of artificial intelligence as we utilize it in a development environment? Well, automated vulnerability detection. We want to be able to analyze code for potential security vulnerabilities while they automatically flag suspicious or insecure coding practices. This helps developers identify and fix security flaws early in the development process. We want to be able to have security best practices, given recommendations and best practices for writing secure code to developers. That way they can offer suggestions on proper input validation, authentication mechanisms, encryption methods, and other security related aspects. This will allow the AI to guide developers to adhere to industry standard security practices. We also want to make sure that AI can be utilized to facilitate code reviews and audits focused on security. They can automatically analyze code bases, identify security weaknesses, and generate detailed reports highlighting potential vulnerabilities for compliance issues. Developer education would be a great example of where artificial intelligence can help. This can serve developers with educational tools offering insights into secure coding practices and secure principles. They can provide contextual explanations, code examples, and interactive tutorials focused on security, empowering developers to enhance their security awareness and proficiency. And of course, with artificial intelligence, they're continuously learning and improving. So AI algorithms can continuously learn from security-related data sources. This ongoing learning process allows artificial intelligence models to adapt and evolve over time. This enhances their ability to detect and mitigate emerging security threats effectively. But of course, that comes with some pitfalls. As I mentioned before, with developers being able to rely on the artificial intelligence more and more, this may lead to a loss of knowledge within the development community. So as AI becomes utilized, there's potential for lost skills of developers as they offload certain tasks to the artificial intelligence. There's also concerns around privacy of intellectual property. AI-assisted tools often require access to large data sets for training and inference, raising concerns about data privacy and security. Developers must ensure that sensitive or personal information is handled securely and that data usage complies with relevant privacy regulations and guidelines. There's also technical limitations, as algorithms are susceptible to technical limitations, errors, and bias, which can affect their performance and reliability. Developers may encounter challenges related to model accuracy, robustness, generalization, particularly in domains with complex or ambiguous problem spaces. And then, of course, there's the unknowns. When we use AI in software development, it's subject to regulatory compliance requirements and legal frameworks governing data protection, intellectual property rights, and consumer rights. And we're seeing a lot of that with copyright material and other types of concerns around where AI is getting its information from, how it's going to be utilized. And honestly, we don't know what that is going to be in terms of the future of AI. So back to our developer that we want to make sure we're keeping happy. The bottom line is that we want to ensure that our developers have the tools to be efficient and secure, and ideally not upset our robot overlords. And I hope you enjoyed this talk on artificial intelligence. Again, my name is Derek Fisher. You can reach out to me on LinkedIn, contact me there, or you can also find more information about me on Securely Built.